Hi, today we're looking at Functional Skills Maths Level 2. This is the AQA exam board. It's the January 2022 paper and we're going to start with the non-calculator section. Question 1. Circle the largest number. Okay, so we can have a look at them as they are, or what I like to do with some of these is to write them one above the other. And you'll see how this makes it easier. And I'm trying to line up my tenths, my hundredths, my thousandths. Okay, so it might not have helped straight away, but what I want to do is I want to get rid of these gaps, so I'm going to put some zeros in. Okay, so we've got, these are our tenths, our hundredths, our thousandths, our tens of thousandths. Okay, now it's a bit easier to compare the numbers. In fact, because they're all starting with a 0, we can actually cover that up and just say, well, let's just compare them as if they were whole numbers. So we've got 7,560, 7,600, 7,000, or 7,516. Well, the 7's the same for all of them, so we just look at the next biggest number. 5 or 6 is bigger than 5, and it's bigger than 0 and 5, so it's going to be this one here, the second one, which is the 0.76. Question 2. Work out 22 minus 7 minus 5 cubed. Now, if you remember your order of operations, we always do the thing in the brackets first. And the thing in the brackets is this 7 minus 5. Well, 7 minus 5 is going to leave us with 2. Okay. But we still keep everything else where it was. So we've still got the 22 minus, and we've still got the cubed. But it's just the thing in the brackets has been worked out. So instead of 7 minus 5 cubed, we've now got 2 cubed. So we've got to look at this and say, well, are we going to do the cubed first or the subtract first? And it's going to be the cubed. Well, 2 cubed means 2 times 2 times 2. So the cube is telling us how many times we're multiplying it together. Well, 2 times 2 is 4. 4 times 2 is 8. So we can now substitute that in here. So the 22 still stays there, and 2 cubed is now replaced by 8. Okay. Well, you can work that out as it is, or we can do it using a column. So 2 minus 8 we can't do. So reduce that to 1 and make that 12 minus 8, which leaves 4. 1 minus nothing is 1. So we've got an answer of 14. Question 3. Work out 5/6 plus 1/3. Okay, well, as you know, when you're adding fractions, you need the denominators to be the same. They're not the same, so we can't just add them as they are. But does one denominator go into the other? Well, yes, 3 goes into 6. So what that means is we can keep this one with the bigger denominator as it is. But this one we're going to need to rewrite, and we want to rewrite it as an equivalent fraction. And because we know 3 goes into 6, we know we're going to be able to write that as something over 6. Well, how many times does 3 go into 6? Well, 3 goes into 6 twice, because 3 times 2 is 6. So if we're doubling the denominator, the bottom number, if we want to keep the value of the fraction the same, we need to do the same to the top number. So 1 times 2 is 2. So saying that 1/3 is equivalent to 2/6. But that's helped us a lot because now we've got 6 and 6 at the bottom. So our answer is going to remain as 6. And we just need to add the numbers on top. 5 plus 2 is 7. And you can leave it like that. Or if you think, well, but 7's bigger than 6. Well, yeah, you've got an improper fraction. So you could say, right, well, how many times does 6 go into 7? Well, it goes into it once, and there's 1 left over. So you can write it 7/6 or 1 1/6. Both are absolutely fine. Question 4. 1.302 divided by 6. Right, well, let's just do this using a bus stop method. Now, it might look a bit strange to use a bus stop method at first, because you think, well, 6 doesn't go into 1, and that's fine. So it goes in 0 times. Put the decimal point. Because we haven't used the 1, we carry it across. So now we say, how many times does 6 go into 13? Well, 6, 12, so that's twice, and 1 left over. So now we've got how many times does 6 go into 10? Well, 1 6 is 6, so that's once. And then 7, 8, 9, 10, that's 4 left over. So how many times does 6 go into 42? Well, we've got to use our 6 times table here. So we're going to do 6, 12, 18, 24, 30, 36, 42. So that's 7 times with nothing left over. So there's our answer. Question 5. Write in digits 27,043,060. Okay, and I put the comma in here that helps. So 27 million, so 27, comma, 43,000. Okay, well, we've got 43,000, but between our commas, we need to have 3 digits. Well, if it's only 43, that means that we must have to put a 0 in here, because we haven't got any hundreds of thousands. And if we don't put that in, well, then it's not going to be correct. Okay, so we've got 27,043,060. Now we've got 60 here, but remember we need 3 digits again. So working from the right, you've always got to have 3 digits, then a comma, then 3 digits, then a comma. So something's missing here. Well, we've got 60, so we've got units, we've got tens, we haven't got any hundreds. So we need to put that in as well. Okay, and always good to check it. So now we look at it and we say, well, I've got 27,043,060. And just for completeness, let's copy that down here onto the answer line. Let's move this up so we can see all of the question. Question 6. Troy works in a call centre. On Monday, Troy receives 15 phone calls. The table shows information about the length of the phone calls. Okay, so we've got ranges here. So it means there were 4 phone calls which were between 0 and 10 minutes. 3 phone calls that were between 10 and 20 minutes. 6 calls that were between 20 and 30 minutes. And 2 calls that were between 30 and 40 minutes. And in total, there were 15 phone calls. Troy has a target to keep the average length of his phone calls to 20 minutes or less. Does the estimated mean time of these phone calls meet his target? Right, so we've got to work out the mean. Now, this bit estimated. When we're working with ranges like this, what the estimated means is that, well, we don't know exactly how long these phone calls were. For example, in these 4 phone calls here, they could have all been 2 minutes, or they could have all been 8 minutes, or one could have been 7 minutes, one could have been 3 minutes. But the estimating is saying, well, let's just say that all the phone calls were in the middle. And halfway between 0 and 10 is 5. So they've done the midpoint for us. Quite often you'll have to work this out, and the way we'd do it is we'd add the 2 numbers together and divide by 2 to find the middle. Let's say they've done that for us. Right, so that means because we've got the midpoint, we don't need to use those ranges anymore. Now, if you remember with mean, to work out the mean, you need the total divided by the frequency. That's a Q, not a G. Frequency. Well, the total is going to be the total length of all of the phone calls. Well, if we do it one bit at a time, there were 4 phone calls that took 5 minutes. So 4 times 5, we can have 5, 10, 15. That means there were 20 minutes in total. So I'm going to put frequency times midpoint. So there were 3 phone calls that took 15 minutes. Well, let's do 3 times 15. 3 5s, 5, 10, 15. 3 times 1, or 1 times 3 is 3. Add 1 is 4, so we've got 45 minutes there. Then 6 calls that were 25 minutes, so it's my times. Well, 6 5s, we've got 5, 10, 15, 20, 25, 30. And then 2 times 6 is 12, add 3 is 15, so 150. And then we've got 2 calls at 35 minutes each. So we could do 2 times 35, or actually we could do 35 plus 35. 5 plus 5 is 10, 3 plus 3 is 6, plus 1 gives us a 7. So we've got 70. So we want to have the total of all of the phone calls. So that's going to be 0 plus 5 plus 0 plus 0 gives us 5. 2 plus 4 is 6, plus 5 is 11, plus 7 is 18. 1 plus the one we carried is 2. So we've got a total of 285. So the mean is going to be 285 divided by the frequency, which they've said is 15. Okay, so this will tell us what the mean is. Okay, now working out 285 divided by 15 isn't that easy without a calculator. You could do it, but it would maybe take a little bit of time. Instead, what he's trying to do, he's got a target to keep the average length of his phone calls to 20 minutes or less. So we can just look at the total and say, well, if he needs them 20 minutes or less, and there's 15 phone calls, well, maybe if we do 15 times 20, then we can compare that to the total length of time of his actual phone calls. So for 15 times 20, I'm going to do 15 times 2 to start with. I'll ignore the 0 and we can put it in afterwards. 2 times 5 is 10. 2 times 1, or 1 times 2 is 2, plus 1 is 3. If we want to put the 0 on the end, we put it on there. Okay, so to meet his target, he needs the total phone calls to be 300 minutes or less. Well, 285 is less than 300. So does the estimated mean time of these phone calls meet his target? Yes, they do. Okay. So if you wanted to do the division, that's fine. But look at these and think, is there another way I can do it? Especially when it's the non-calculator section. Okay. 6b. Customers are asked to rate their experience of the call centre from 1 to 5. The chart shows some ratings. Okay, so let's see this chart here. So we've got the rating. Let's move this up so we can get that in, yeah. So the rating is either 1, 2, 3, 4 or 5 stars. The frequency, so how many ratings they got. So the 1 stars, we got 1, 2, so there were 3 ratings there. So there were 3 1-star ratings. The 2s, there were 9, so there were 9 2-star ratings, and so on. A rating of 1 or 2 is poor. Work out the fraction of these ratings that were poor. Give your answer in its simplest form. Okay, well, we already started to work these out, didn't we? We kind of had a look across here and said, well, that's 1, 2, 3 for 1, and for 2, that's 9. So poor is going to be 3 plus 9. Or if we start with 9, 10, 11, 12. So if it's going to be as a fraction, it's going to be 12 over, and it's going to be over the total number of reviews that we got, okay, or the calls to the call centre. So we know that, actually I'm going to write it on here. So that's 3, that's 9. How many 3-star ratings were there? Well, I can start from 10 and count up, but actually it's closer to 20. So I can say that would be 19, that would be 18. The 4-star ratings, this is 30, so 31, 32, 33, 34. And our 5-star ratings, well, that's 20. This line here is 25 because it's halfway between the two. So that must be 26. So if we want to know how many there were in total, we'll do 26 plus 34 plus 18 plus 9 plus 3. 6 and 4 is 10. Add 8 is 18. Add 9 is 27. Add 3 is 30. Now we've got 2 plus 3 is 5, plus 1 is 6, plus 3 is 9. So in total there were 90 of these calls or reviews, and 12 of them were poor. Now they want this given in its simplest form. Well, we want to say, well, what numbers go into both of these? What are the common factors? And they're both even numbers. So let's start off by saying, well, let's divide both of them by 2. Well, 12 divided by 2, I know half of 12 is 6. We want half of 90 as well. So I'm going to do the bus stop method. So 90 divided by 2. Well, 2 goes into 9, 2, 4, 6, 8. That's 4 times with 1 left over. And 2 goes into 10, 2, 4, 6, 8, 10. That's 5 times. So that's going to be 6 over 45. So we've just halved both of these numbers. Now, is there any more common factors? Any numbers that go into 6 and into 45? Well, it can't be 2 because 45 is an odd number. So the only other number maybe, what about if 3 goes into these? I know 3 goes into 6. What about if 3 goes into 45? Let's try. And remember, it needs to go into it without any remainder. Well, 3 goes into 4 once, with 1 remainder. And 3 goes into 15. 3, 6, 9, 12, 15, 5 times. Okay, so we can divide both of them by 3. We've already seen that the denominator goes down to 15. 45 divided by 3 was 15 over here. So we want 6 divided by 3. Well, 3, 6, that's just twice. Okay, and we know we can't make it any simpler because the only numbers that go into 2 are 1 and 2. And dividing by 1 is not going to make it any smaller. And we can't divide 15 by 2 because it's odd. So we stop there. C. 1 year, Troy is paid a salary of £20,370. I'm going to put the comma in there to make it easy to read. That year, he pays income tax on this salary at the rate below. So up to £12,570 up to £12,570, he pays no tax. For anything above £12,570, he pays 20%. Okay. Troy also pays £1,296.24 in national insurance. Work out the total amount of income tax and national insurance Troy pays that year. So the first thing we need to do is to work out how much tax he pays. Well, we know his salary is $20,370, so he's going to be paying a rate of 20%. But he's not paying 20% on all of this. It's only on his salary or his income above 12,570. So we've got to find out what the difference is between these amounts. So 20,370 subtract 12,570. And this is the way income tax works for everyone. You don't have to pay tax on the first amount, so we can take it off. So 0 minus 0 is 0. 7 minus 7 is 0. 3 minus 5 we can't do, so I want to take one from the 0, but we can't. So we reduce the 2 to a 1, make that a 10. Then we can reduce that to a 9, pass 1 over, so we've now got 13 minus 5, which is 8. 9 minus 2, which is 7. 1 minus 1 is 0. So we can put 0 or leave it out. Okay, so it's going to pay 20% tax on £7,800. Okay, so let's just make that nice and clear. Right, well, if we want 20% of that, we're doing it without a calculator still. So we could do 20 divided by 100 times 7,800. I'm just going to say, well, I know that 10% of 7,800 would be, well, I just take the 0 off. It's going to be 780. So if it's 20%, well, it's going to be double that. So 20% of 7,800 is going to be, well, 2 times 780. Okay, so let's do that. Or actually, let's call it 780 plus 780. Yeah, it's exactly the same. 2 times 780, you're just adding it together. So 0 plus 0 is 0. 8 plus 8 is 16. 7 plus 7 is 14. Plus the 1 is 15. So his total tax is £1,560. But remember, they want the total of his tax and national insurance. So we're going to want this 1,560. I'll write it over here so we don't confuse it. And we need to add on the national insurance, which is £1,296.24. Well, so we've got something to add it to. I'm going to put zeros in there. So 0 plus 4 is 4. 0 plus 2 is 2. 0 plus 6 is 6. 6 plus 9 is 15. 5 plus 2 is 7. Plus 1 is 8. 1 plus 1 is 2. So we've got a total of £2,856.24. And that's the end of the non-calculator section. Okay, so now you can get your calculators out. So for the calculator section, this is question 1. Here are 6 numbers. Work out the median. Circle your answer. Okay, so the median is the middle number. So we need to have them ranked from smallest to largest. Okay, well, they've already done it for us. We've got 3's the same, but then they're getting bigger, so that's fine. So we can cross out the smallest and the biggest. We keep doing that in pairs till we're left with either one number or 2 numbers. Well, if we've got 2, we add them together and then divide by 2. So with the calculator, 3 plus 4 divided by 2, we get 3.5, which is that number there. Question 2. Here is a scale. 2 centimetres represents 5 metres. What does a length of 7.2 centimetres represent? Well, I'm gonna go backwards. I'm gonna say, well, if 2 centimetres is 5 metres, what would 1 centimetre represent? Well, 1 is half of that. So basically what we want to do is divide the 5 by 2. So 1 centimetre represents 2.5 metres. Okay. Now, if we want 7.2 centimetres, well, 7.2 lots of 1, so it's going to be, we want 7.2 lots of 2.5. We've still got the 2.5 from before, multiply by the 7.2 to give us 18 metres. And we've got to remember the units. Okay, so the centimetres is before we've applied the scale. Once we've applied it, it's then metres. Question 3. Work out the value of a squared minus 4b when a equals 3.6 and b equals 1.7. So we've got a bit of algebra here. All we need to do, or the first thing we do, is we write this again, but we replace the letter with the value. So a squared becomes 3.6 squared. And minus 4, and the b becomes 1.7. But because it's a number next to a letter, we need to put a times in there. So 4b means 4 lots of b, or 4 times b. Right, so we're going to do the squared bit first. Well, 3.6 squared means 3.6 times 3.6. which is 12.96, and then minus, but remember order of operations, we do the multiply before the minus or the subtraction. So 4 times 1.7 gives us 6.8. So 12.96 minus 6.8 gives us 6.16, which we can write down there. Question 4. Write these fractions in order, starting with the smallest. Okay, so if you're thinking, right, okay, well, let's get our denominators the same, then we can compare. That would be great if it was the non-calculator section. This is the calculator section, okay? We haven't got time to waste doing complicated things like that. We just say, well, 13 over 20 is 13 divided by 20, which is 0.65. 27 over 40, well, that's 27 divided by 40. That's 0.675. 3/5, or 3 over 5, is 3 divided by 5, which is 0.6. If we want to be able to compare them nicer, well, this has got 3 decimal places, so let's put a 0 and 2 zeros there. So now we've got 650, 675, 600. This is the bigger number. So, we're starting with the smallest. So the smallest, 600, is smaller than both of those. So we have the 3/5. Then the next one is the 650. So then it's going to be 13 over 20. And then the biggest one, 27 over 40. Okay. Without calculating the exact value, so without, use approximations to estimate the answer to 376,025 times 6.1. Right, so they've said without calculating the exact value, and then they've said use approximations. So you're not going to get full marks if you actually type that in your calculator. They want you to do some rounding. Okay, exactly how you round it is up to you. 376,025. Well, we could round this to 376,000. You could also round it to 400,000 if you want to round it to the nearest 100,000. I'm going to go with this one. Okay, either would be fine. You're doing something that's sensible. Times 6.1. Well, the obvious one to round 6.12 is just going to be to 6. So if we do 376,000 times 6, we get 2,256,000. So there could be more than one right answer. So probably the other one you might have done is round that to 400,000. You could round that to 10 if you want to round the nearest 10, but I've gone with 6 there. Okay, so 2,256,000. Question 6. Complete the table to show equivalent fractions, decimals and percentages. Right, well, decimal, we want to turn it into a percentage, or we can do the fraction. Well, I know to get from a decimal to a percentage, we multiply by 100. So that's 4%. So if we want to go the opposite way from percentage to decimal, we do 23 divided by 100, which is 0.23. So we want to go to decimal. No, oh no, sorry, that's a fraction. Silly me. We've already got the 0.23. So percentage 23 out of 100. So we just write it as 23 over 100. Sorry, that's me going too quick and not paying attention. This is the one. If we want to go from percentage to decimal, well, you saw when we went from decimal to percentage, we multiplied by 100. So if we divide by 100, and we've got to have the 0.7, divide it by 100, we get 0.007. Make sure you get the 2 zeros in there, because it's 0.7, so it's less than 1%. Okay, 1% would be 0.01. It's less than that, so we've not just gone into the tenths and hundredths, but we've gone into the thousandths. So tenths, hundredths, thousandths. So this would be 7 thousandths, which is exactly what's written there as a fraction. So we could have gone from here to there instead. Question 7. Jam. Daisy makes jam and sells it at a farmer's market. Daisy makes 24 jars of blueberry jam. The table shows the cost of the ingredients and jars that Daisy needs. So for blueberries, she needs 4.5 or 4.5 kilograms, and it costs £1.79 per 150 grams. Sugar needs 5 kilograms, it's £2.08 per kilogram. Lemon, she needs 4 of them, they're 17p each. Glass jars, she needs 24, and they cost £3.90 for 6. How much will it cost Daisy to make the 24 jars of jam? Okay, so we've got to work out the cost for all of these things and then add them all together. Right, start with the blueberries. 117 or £1.79 per 150 grams. Well, how many 150 grams do we need? Well, they've given us the weight we need in kilograms. Well, I know that there are 1,000 grams in 1 kilogram. So let's turn this into grams, because then we're working with the same units. So 4.5 times 1,000. So this is equal to 4,500 grams. So how many 150 grams do we need? Because it's £1.79 for every 150 grams. So if we know how many times 150 goes into this, we can multiply it by the £1.79. So if we do 4,500 divided by 150, we get 30. So for this, we're going to want 30 times £1.79, which is 53.7 pounds and pence, so we've got to put a 0 at the end, so £53.70. So that's for the blueberries. For the sugar, she needs 5 kilograms, it's £2.08 per kilogram. So this one's more straightforward, we just want 5 lots of £2.08. Which is £10, and again it's pounds and pence, £10.40. Lemons, 4 times 17p each, So 4 times 17, but I'm going to write it as 0.17. So I'm doing it as if it's money. And that's going to make it easier for when we're adding these all together. So 4 times 0.17 is 68p, but I've written it in pounds, so 0.68 pounds. Glass jars, she needs 24 of them. It's £3.90 for 6. So what we can do is say, well, let's work out how much it costs for one. So £3.90 divided by 6. So it's 65p or 0.65 pounds per jar. So that's for one jar. We want 24 of them. So we're going to do 24 times 0.65. 0.65 times 24. So that's £15.60. So we need the total cost. So let's go from bottom to top because we've already got this in the calculator. So £15.60. Add the 68p. No, what did I do there? £15.60. Add the 68p. Yeah, that looks better. Add the £10.40. That's why it's good to check what you're doing as you're going along. So £15.60, I'm adding something less than £1, so I know if this goes to more than 16 something, it's wrong, okay? And then we add 10 onto that, well then it should be £26 something, which it is. So when I add on 53, well in my head I'm thinking, well 26 is about 30, 53 is about 50, so 30 plus 50, my answer should be about 80. So let's see, if we add £53.70, we get, yeah, £80.38. Okay, so I know it's I'm doing it quickly with the rounding, but do check these. Don't just do it blindly on the calculator. Say, does this look sensible? Is it what I'm expecting? Okay, so that's our answer. (7b). The glass jars are in the shape of a cylinder of radius 3.4 centimetres. Well, let's have a look at that. A cylinder. So that's a circle with straight edges. Okay. The radius, so that's from the centre to the edge, 3.4 centimetres. Daisy fills a jar to a height of 7.5 centimetres. Okay, so if we're just looking at the bit that she fills it to, it's going to be 7.5 centimetres. Work out the mass of the jam in the jar. Okay. Oh, I missed out this bit. 1 centimetre cubed of jam has a mass of 1.29 grams. So what we need to do is work out how much space the jam takes up and then multiply that by 1.29 to give us the total weight or the total mass. So if we want the volume, well, if it's a volume of a cube, then we multiply the 3 dimensions, length times width times depth. When it's a cylinder, it's similar, but what we're doing is we need the area of the circle, and then we need to multiply that by the height. Okay, well, let's start off. What's the area of the circle? Well, the area of the circle is pi r squared, where pi is 3.14. It's next to the r, so that means times. R is the radius, which is 3.4, and it's squared, so it's times itself. So 3.14 times 3.4. Be careful here, because we've got 3.14 and 3.4. So that gives us an area of 36.2984, and its area, so it's centimetres squared. Okay, I'm going to keep all of those digits in my calculator. We need to multiply it by the height. So we're going to multiply that by 7.5. And we get 272.238 centimetres cubed, because that's now the volume. Okay. Now, for each centimetre cubed, the jam has a mass of 1.29 grams. So we now want to multiply that by 1.29. And I've just left it all in my calculator, so I don't have to keep typing these things in. 1.29, and we get 351 point. Have they told us to round it? No, I'm going to round it to, I'll round it to 2 decimal places. 1/8. This is 7, it's more than 5, so I'm going to round it to 1/9, and that's now going to be in grams. In fact, they've written grams down here, so we can put 351.19. Seven C. Daisy has 60 jars of jam to sell at a farmer's market. She sold 42 jars at £4.50 each. She then reduced the price. She sold the remaining jars at the reduced price. Daisy received £245.70 from the sale of the 60 jars. By what percentage did she reduce the price? You must show your working. Right, so there's a lot going on here. We can see we've got 6 marks. So we know there should be about 6 steps involved. Right, it's not going to be a super quick question. Doesn't mean it needs to be difficult though. We just have to split it down step by step. Okay, so the first thing we can do is we can say, well, if we want to work out the percentage of the reduced price, we want to know what that reduced price is. And we can start off by saying, well, we know that she sold 42 jars at £4.50 each. So let's work out how much money she got for those ones. So 42 times £4.50 is £189. Okay. She received £245.70 for all 60 jars. So let's find out how much money she made from the other jars. Well, in fact, before we even do that, we can say, well, if there were 60 jars to start with, she sold 42 of them. How many are left? So that's 18 jars left. Okay. So now we can say how much money did she get for those 18 jars? Well, it's going to be £245.70 minus the £189 that we know she did get for those 42 jars. So that's £56.70, and that is for 18 jars. So how much did each jar cost at the reduced price? Well, it's going to be £56.70 divided by 18. So the reduced price is £3.15. Okay? And that's a good start because it is less than the original price. So that's what we'd want to see. It's reduced. It's gone down. Good. By what percentage did she reduce the price? Well, let's start off by working out by how much she reduced the price. So £4.50 minus £3.15 means it was reduced by £1.35. Well, what's that as a percentage? Well, it's going to be £1.35 out of the original amount, so divided by £4.50. So 1.35 divided by 4.5, and that's going, well, what I should have said was we want to turn it into a percentage, so we're going to multiply that answer by 100. So 0.3 times 100 is going to give us 30%. Okay. So we find the way I did it before, that was as a decimal. So we've just got to remember it's percentage, we multiply it by 100. That then gives us the 30%. So it's still quite a bit of work, and it's still 1, 2, 3, 4, 5, 6 steps to get the marks, but it's not actually taking up loads of space. And each individual step hopefully makes sense and it's clear why we're doing it. So just because it's a lot of marks doesn't mean we need to panic. Question 8. Electric car. Jamal has an electric car. The car is powered by a rechargeable battery. Jamal installs a charging point to charge the car at home. The government pays 40% of the cost. Jamal pays £525. Work out the full cost. Right. What we definitely don't want to do is work out 40% of this, because this isn't the original amount. The government isn't paying 40% of this. The government is paying 40% of what it costs to charge the car. And we don't know what that amount is. What we do know is that if the government is paying 40%, well, Jamal must be paying the rest. So 100% minus 40% is 60%. So this amount represents 60% of the total cost. So we want to find out what the total cost is, so what 100% is. So what we can say is we can do £155. If we divide it by 60%, because that's what it represents, that's going to tell us how much it costs for 1%. So it's £800 or £8.75 for 1%. So if we want the full amount, 100%, we times it by 100, we get £875. (8b). Jamal wants to know the approximate cost of the electricity used for a car journey. He records information about the miles driven and electricity used, that's in kilowatt hours. But again, if you don't know what it means, it's just the units, so don't worry about it. For 12 journeys. 10 of the journeys are shown on the scatter diagram. Okay, we've got them plotted out here. So we've got the miles here and the kilowatt hours. So that's how much electricity. So it sort of looks like the more miles you travel, the more kilowatt hours you use, which probably makes sense. The table shows the extra data for the other 2 days. Okay. So miles driven, so the 60 miles driven, it used 21 kilowatt hours, and when 84 miles were driven, it used 32. 1 kilowatt hour of electricity costs 15p. Use the scatter diagram with the extra data to estimate the cost to drive 80 miles. You must show your working, some of which should be on the diagram. Okay, so we're going to use that information, but they've said that we need to use the extra data. So I've got to plot these 2 points on my scatter diagram. So 60 miles driven. 60 miles, 21 kilowatt hours we used, so 60, so that's 20, so that's 21. Put there. Then 84 miles were driven, well, here's 80. Well, look, from 80 to 90, we've only got 5 boxes, so we must be going up in 2s. 82, 84, 86, 88, 90, yeah. So for 84, we're going here, and then we want to go up to 30. Now, on this scale, we are going up 1, 2, 3, 4. We're going up 1 each time. So 32 is actually going to be there. Yeah, see, bring it down a little bit so you can see that better. So we've got to use this scatter diagram to estimate the cost to drive 80 miles. Well, before we can do something with it, because we've just got a load of points, we need to draw a line of best fit. So that's where we draw a straight line that goes through all the data, not beyond it. So we're going to start here and we're going to finish across here. Doesn't need to go through any of the points. If it does, that's okay. It's got to be a straight line which follows the overall pattern with the same, roughly the same number of points above the line as below the line. Okay, and now we can use that. So we want to use it to estimate the cost to drive 80 miles. Well, if we get 80 here, we'll draw a line up to here and go across. It's slightly above. So it's coming out here, which is 29. It's maybe slightly over it, but it says approximate. So I'm going to take this value and we're going to say it's 29 kilowatt hours used. Okay, they want the actual cost of that. So if you remember, 1 kilowatt hour of electricity costs 15p. So we're going to have to do 29 times 15, which is going to be 435. Remember, that was p, or pence. So if we want to turn that into money, and in fact you'll see that the space for the answer has got a pound there, we're going to need to divide that by 100. Or you'd probably just look at that and say, oh, 435 pounds, sorry, 435p, I know that's going to be £4.35. But what we're doing is we're dividing it by 100 to get our cost. Now you might get a slightly different answer depending on how you drew your line of best fit, but it should be close to that. And it's okay if you do get a slightly different answer. They allow a range for these types of questions. Okay, question 9. Fitness gym. Nicole manages a fitness gym. One week, Nicole recorded how many people used the rowing machine. From Monday to Friday, the mean number of people who used the machine was 21 per day. From Monday to Sunday, the mean number of people who used the machine was 26 per day. 32 people used the machine on Saturday. How many people used the machine on Sunday? Right. Yeah. So, how are we going to do this one? Well, when we've got lots of words with a question like this, we need to try and turn it into numbers, make it maths, so we don't have so many words that can easily confuse us. So we want to start off by thinking, well, let's start with what we know. We know Monday to Friday, the mean number of people was 21 per day. Well, Monday to Friday, you've got Monday, Tuesday, Wednesday, Thursday, Friday. So that's 5 days. So 5 times 21 is going to tell us how many people use the gym from Monday to Friday. So we've got 105 people. Because what we can do, if we can work out how many people use the gym in total, then maybe we can work out how many people work them on certain days, and we'll hopefully just be left with however many people use the machine on a Sunday. So, from Monday to Sunday, the mean number of people who use the machine was 26 per day. So that's sort of saying, like, well, the total number of people divided by 7, because there's 7 days in a week, Monday to Sunday, gives us the answer of 26. So we can use this to work out, well, how many people were there in total? Well, if something divided by 7 is 26, well, if we do the opposite of divide is times, so 26 times 7 means that the total number of people must be 182. So 182 people, and I'm going to put, that's for 7 days. Yeah. And we know how many people use it for 5 days. So Monday to Friday. So what can we do with these numbers? Well, if we do 182 minus 105, that's going to be how many people use the machine over the weekend. 77 on Saturday and Sunday. Okay, so we've taken the full week, taken off the people that use it on the weekdays, so we're left with Saturday and Sunday. Well, we know 32 people use the machine on Saturday, so if we do 77 minus 32, that should leave us with how many people use the machine on a Sunday, which is 45 people. 9b. The gym has 2 classes on one day. The Venn diagram represents the members who attended at least one class. Okay, at least one class. So they might have attended just one of them, they could have attended the other one, or they could have attended both. So we've got a Zumba class. So 36 people just attended the Zumba class. 17 people attended just the yoga class. And 14 people did the Zumba class and the yoga class. One of these gym members is chosen at random. Work out the probability that the member attended exactly one of the classes. Right, well, how many people have we got in total? So we want 36 plus 14 plus 17. Okay, that's going to give us all of the people that did a class. $67. Okay, and so when we do our probability, that's going to be our denominator. We want the probability that the member attended exactly one of the classes. So exactly one is going to be either the 36 or the 17, which is 53. So it's going to be 53 out of 67. And that's it. We can leave it as a fraction. In fact, that's the best way to leave your answer. Part C. Lottie and Emma visit the gym. They both exercise by running on the treadmill. Lottie runs for 36 minutes at an average speed of 7.24 miles per hour. Emma runs 4.125 miles. How much further did Lottie run than Emma? Right, so we want to work out how many miles Lottie ran so we can compare it to Emma's. Okay, so she's doing 7.24 miles in 1 hour. Well, 1 hour is 60 minutes. She's only running for 36 minutes, so you can think of it as 36 out of 60. Okay. Which, if we just work that out on its own, that's 0.6. We can think of it as 60%. Okay, well, if it was a whole hour, it would have been 7.24 miles. Because it's only 0.6 or 60% of an hour, we can multiply that by 7.24 to tell us how many miles she ran. So 4.344 miles. How much further did Lottie run than Emma? Well, it's going to be the 4.344 minus the distance Emma ran, which is 4.125. Which is 0.219 miles. Question 10. craft business. Ross runs a craft business. She makes teddy bears and cushions. Part A. Ross has £350 to spend on a new sewing machine. She buys this sewing machine. Sewing machine was £395, now 17% off. How much of the £350 does Roz have left? Right, so we want to take this off. So we can work out what 17% is first of all. So we can do 17 out of 100 times 395. Okay, this is going to give us how much the discount is. Which is £67.15. So we're taking that off. So we want 395 minus £67.15. That's going to tell us how much it actually cost. So £327.85. Okay. Well, if she's got £350 to start with, and she spends £327.85, how much is she going to have left? And it's £22.15. (10B). Ross makes circular cushion covers. Each cover has a zip. She uses these steps to work out the length of zip needed. So step 1, use the diameter to work out the circumference of the cover. Step 2, divide the answer to step 1 by 2. Step 3, subtract 1/4 of the diameter from the answer to step 2. A cushion cover has a diameter of 16 inches. Work out the length of the zip in centimetres. Use 1 inch equals 2.5 centimetres. Right, lots of words again. Another one of these questions. We're starting off, let's go back and read it again. She makes circular cushion covers. So that's my best attempt at a circle. Okay, and we're told a cushion cover has a diameter of 16 inches. So the distance from side to side going through the middle is 16 inches. Right, now they said we've got these steps to work everything out. So they haven't told us at what point we need to go from inches to centimetres. I'm going to stick with my inches for now, and then I'll turn them to centimetres at the end, I think, and we'll see if that's if that works out okay. So step 1, use the diameter, which is 16 inches, to work out the circumference of the cover. Well, the circumference is equal to 2 pi r, but you might know it as pi d, okay, where d is the diameter. So 3.14 times the diameter, which is 16 inches, which is 50.24 inches. Okay, so that's step 1. Step 2, divide the answer to step 1 by 2. So 50.24 divided by 2 equals 25.12 inches. I'm putting the units down every time because we've got centimetres and inches going on here, so I don't want to get confused. Step 3, subtract 1/4 of the diameter from the answer to step 2. Right, there's quicker ways you can do it, but I'm going to do it what I think it makes most sense. So we want to work out what 1/4 of 25.12 is. So we can divide that by 4. 6.28, and it says subtract 1/4 of the diameter from the answer to step 2. So we want 25.12, which was the answer, minus the 6.28. Now you might be thinking, well, if I'm subtracting a quarter, can't I just work out 3/4? And yes, you can. That's what this represents. Okay, so we've got 18.84 inches. No. Subtract 1/4 of the diameter. So not a quarter of step 2. Sorry, my mistake. A quarter of the diameter. The diameter was 16. So a quarter of 16 is 4. Yeah, my mistake. So it's 4 we want to take off of that. 25.12 minus 4. 21.12 inches. Yeah, it's important to read the question carefully. We want the length of the zip in centimetres. Well, we've got the length of the zip in inches. If 1 inch is 2.5 centimetres, well then we need to multiply the 21.12 by 2.5. And we get 52.8, and that is now in centimetres. (10C). And this is the last part of the question paper. Ross makes small teddy bears and large teddy bears. She fills the teddy bears with wool. The weight of wool she uses for each bear is in the ratio, so small teddy bears to large teddy bears is 2:3. Ross uses 560 grams of wool to fill 1 small teddy bear. How many large teddy bears can she fill from a 10 kilogram bag of wool? Right, well, this is a ratio question, so I'm going to draw a ratio table for myself. So let's straighten this out. So in my table, I'm going to put small teddy bears, large teddy bears, and then we're going to have a total as well. We might not need the total, but we'll see. It's always good to have it there. So the ratio is 2 small to 3 large. So if we only had 2 small and 3 large teddy bears, that means we'd have 5 in total. Now, Ross uses 560 grams of wool to fill 1 small teddy bear. So we can put that down here. So what we're trying to work out is how much wool we need to fill the large teddy bears. And then we can use that to work out how many we can make from our 10 kilogram bag of wool. Okay, well, how are we getting from 2 up to 560? Well, we need to do it in reverse and do 560 divided by 2. So that's 280 grams. No, sorry, not 280 grams, it's just 280. Okay. So we're working out a multiplier. Yeah, it's because if we know that, we can do the same to the large. Which gives us 840. Okay. So that's saying that it takes 840 grams for 1 large teddy bear. Okay, because this wasn't 560 grams for 2 small ones, it was 560 grams for 1 small teddy bear. It's just we've used this ratio to get us the 840. Okay. You could think of it as 3 is 1.5 times bigger than 2, so you can work out 1.5 times more than 560 is 840. But I find with these tables, it's just easier if we write out the ratio, put the new number in the correct column, work out what the multiplier is, and then just use that on the column that we are trying to work out. Okay, so we know 840 gram of wool for 1 large bear. Okay. Well, we've got a 10 kilogram bag of wool. Well, there's 1,000 grams in 1 kilogram. So 10 kilograms is going to be 10 lots of that, which is going to be 10,000 grams. So we want to know how many 840 grams of wool we can get from 10,000 grams. So 10,000 divided by 840 gives us 11 I'll do it to 2 decimal places, 90. That's less than 5, so we can leave it like that. 11.90 teddy bears, and that's large ones. Well, you can't really fill 0.9 of a teddy bear, so we're going to have to go with the number of complete teddy bears we can make, which is 11. And that's the end of the paper. So I hope you found it helpful. Please like the video, subscribe to the channel, have your notifications turned on, and I look forward to seeing you again soon. Thank you.